Okay, so yesterday we were talking about exponential growth, right? When the thing I have is getting bigger. And we looked at a couple examples of that, and we had a formula that we could use to model exponential growth for problems where I had this sort of starting amount, this initial population, or this initial amount of money you saw for a lot of your homework problems. And then that amount was increasing at a specific rate, at a set rate. Today, we're going to look at exponential decay. So same idea, except for this time, instead of my amount growing, my amount is going to be decreasing, okay, over time. So for exponential growth, we're increasing over time. For exponential decay, we're decreasing over time. Notice that our formula is really similar to what we saw yesterday for exponential growth. We still have that initial value. We still have that rate that we're changing by. The difference this time is that we are subtracting. And that should make sense, right? If the amount we're having is reducing each time, we're subtracting off that rate. So same idea. And then the other small change that we see here is I used an x for my exponent yesterday, but we've got a t here instead. That means the same thing. We're using a t here because for most of our problems, we're going to look at this over a period of time. That will be sort of our x value is time. So they use t since it typically represents time for a lot of our exponential functions. If you like x better and you want to write it with x, that's fine too. So let's take a look at a couple of examples, similar to what we looked at with our homework yesterday, okay? So for example 1, this says the original price of the tractor was $45,000. The value of the tractor decreases at a steady rate of 12% per year. Who has ever heard, usually in reference to buying a new car, the second you drive it off the lot, the value goes down? Yeah, that's true of a lot of things. As soon as we buy them, if I then tried to turn around and sell it, I'm not going to get as much as what I paid for it. The value of stuff decreases over time. So that's what we're looking at here. The value of our tractor is decreasing at a rate of 12% per year. So we're going to write the equation to represent the value of the tractor since it was purchased. So here I have my initial amount. Here I have my rate. Remember, we're going to write this as a decimal. So I need to move that decimal 2 places, so 0.12. And so my function would be y equals 45,000 times 1 minus, since our value is decreasing, 1 minus 0.12 to the t, or to the x for your power if you'd rather. Again, really similar to what we did yesterday, okay? So here are the last couple of problems we looked at yesterday. Same idea, but we were adding. Now we're subtracting because that amount is decreasing. So now if I want to find the value of the tractor in 5 years, I'm going to plug in 5 for t. So y equals 45,000 times 1 minus 0.12 to the 5th power. I heard some calculators open, which is great, because that's what we're going to do next. At this point, we've done this before. We've done this since the start of our unit, plug in values for an exponent and simplify or evaluate. So I'm going to do the same thing here. So 45,000 times, in parentheses, 1 minus 0.12 to the 5th power. We get 23747.9363. Since this is money, I want to round to the nearest penny. So that would be 94. $23,747.94. Questions for me on example 1? So again, this is the value of our tractor in 5 years. Let's take a look at example 2. A house valued at $120,000 in 2014 is expected to depreciate. That means my value is reducing. Appreciate would mean my value is increasing. Here we have depreciate, so my value is going down. Depreciate in value by 1.5% yearly. How much will the house be worth in 2020? So I'm going to start by writing a function. Here's my initial value, and here's my rate. Remember, I want to write this as a decimal, so that would be 0.015. So my function here would be 120,000 times 1 minus 0.015 to the t. And then I want to figure out what the actual value of that house will be in 2020. Now, I need to be careful when they've given me years like they have here. I don't want to plug in 2020 for my exponent. Okay. T is always measuring how much time it's been since my initial amount. Okay, since that initial measurement that I took. So we looked at our house value in 2014. How much later is 2020? Yeah, so I want to plug in 6 for T. This is going to be after 6 years. So this would be 120,000 times 1 minus 0.015 to the 6. Go ahead and type that in your calculator and let me know what you get. Again, this is money, so we want to round to the nearest penny. Anyone have this for me yet? Mary? Perfect. $109,596.99. That would be the value of our home in 6 years. Question? Who didn't get the pennies? Okay, so that's a float issue on your calculator. Float is your calculator's way of describing how many places it's going to show you. So here's what I want you to do. On your calculator, I want you to hit the stop key. And then I want you to go down to settings and status. And then I want you to go to document settings. The top sort of category in your box here should say display digits. Do you guys see that? Okay. So I have mine set to float 9. I believe the default for your calculator is float 6. So that means it's going to give you 6 digits. So if it's 12.9732158, whatever, and it's a big decimal, it'll give you 6 total digits. If it's just a really big number, like 100 million and something, it's going to give you 6 digits and then scientific notation. Since we had 6 digits here, Pam, you need to mute yourself, please. Thank you. Okay. Since we had 6 digits before the decimal here, that's why it rounded that number for you. Does that make sense? Okay. So we lose some precision though when we don't have a high enough float. So I want you to go in here and change it to at least 9. I think the biggest you can get is 12, but we're going to go with 9. And then you can leave all the rest of it the same. I'm going to go ahead and apply it to everything. And then once you change that, if you arrow back up to select what you typed in and hit enter, sort of paste it in your new line, hit enter again, and it should give you those decimal places. Did that work for you? Yeah, okay. If you ever feel like you're not getting enough digits or you get scientific notation and you don't think you should have, adjust your full sentence. Okay. Any other questions on example 2? Let's hop down to example 3. The population of Bulgaria has been decreasing at an annual rate of 0.89%. If the population of Bulgaria was about 7.5 million in the year 2005, predict its population in the year 2015. The same idea as what we just worked on. We have our initial population of 7.5 million, and then we have our rate of decrease. Remember, I want to write this as a decimal, so I can move that decimal 2 places. So when I go to write my function, I'm just going to use 7.5 with the understanding that our answer is going to be in millions. So if I get 4 for an answer, that would be 4 million. Okay? So 7.5 times 1 minus 0.0089 to the 2. Yeah, you could also, if you wanted to, write 7, 500, 000. And then your answer would, by default, be already set up in millions. What do we want to use for t here? 10, yeah. We took our initial sort of measurement in 2005. I want to know what will be the population 10 years later. So what will be our population in 10 years? So I'm going to go ahead and round this to, let's say, 6.9 million. Now, it should make sense that our population in 10 years is less than our population when we took our first measurement, right? Because that population is reducing. Questions for me on example 3? Okay. So if you would for me, please hop over to the next page, page 16. And I actually want to jump down to number 4 at the bottom. So at the bottom of page 16, looking at number 4, we have a bunch of different exponential functions given to us here. And we want to, just from the function, determine if we have exponential growth or exponential decay, and then identify that rate of growth or decay. So here's what I want to remind you from last time. So when we were working on setting up those problems from our homework last time, we said that there are actually 2 different functions I could write that would mean the same thing. One version where I had 1 plus that rate, and then another version where I actually just went ahead and added, right? And so these are the same thing. I just went ahead and sort of simplified what was inside parentheses. And then same thing here. I had 1 plus 0.22. The other option would be just to go ahead and add them together and you get 1.22 as the base for your exponent. These mean the same thing. I could do the same thing for my exponential decay function. So here I could also, if I wanted to, write this 40,000 times 0.88 to the fifth power. 1 minus 0.12 is the same as 0.88. So these mean the same thing. They're equivalent. Does that make sense? Okay. So as we're looking at our functions at the bottom of page 4, that's what they've done. They've gone ahead and simplified what was inside parentheses. And so we want to determine, based on that number, do we have exponential growth or exponential decay? If I had 1 plus something, then the base for my exponent should be bigger than 1. If I had 1 minus something, then the base for my exponent should be less than 1. So if I look at A here, that number is less than 1. That means I had 1 minus something in parentheses, which means that this would be a decay function. Looking at exponential decay here. If the base for my exponent is less than 1, I have decay. If I were to look at a graph, I would expect that y value to go down over time. And then the other piece of information I want is, what was that rate of, in this case, decay? So I know in parentheses I had 1 minus whatever that thing was, and that gave me 0.95. I could figure out that rate by taking 1 minus 0.95. That would give me the rate that I subtracted originally. Okay? So that means our rate had to be 0.05 or 5%. Questions for me on A? Make sure where I got 5% from. Okay. Let's take a look at B. For B, the base for my exponent is bigger than 1. Since this is bigger than 1, that means it had to be a 1 plus situation, which means this is exponential growth. And if I were to look at a graph, my y values would be going up over time. Now, I think that it's a little bit easier to figure out that rate of change when you have exponential growth, because you're only looking at how much bigger than 1 am I. So that means our R had to be 0.025. So our rate would be 2.5%. Questions on B? Okay, let's take a look at a couple more. For C, is this going to be growth or decay? Decay. The base of the exponent is less than 1, so this is decay. And then if I take 1 minus 0.91, I would get that rate. So what's our decay rate? 0.09, which would be 9%. Very good. And then one more down here for E. Is this growth or decay? This is growth. The base for my exponent is bigger than 1, so this is growth. What's my growth rate here? Yeah, I'm 0.14 bigger than 1, so that would be 14%. I'm increasing by 14%. Questions for me for today? Okay, so you have a couple problems left for number 4. And then 1, 2, and 3 are the same types of problems that we did together on page 15. Okay, same setup, same idea. You also will have 3 Khan Academy assignments that I'm going to release here in just a second. 2 of them are related really closely to stuff we've looked at today. So for one of them, you are writing exponential decay functions okay, just like we did today in class. I have another where you're gonna determine for me whether the representation you have is exponential growth or exponential decay. So if we have a function like we had down here, is it growth or decay? Or if I have a graph, maybe, am I representing exponential growth or decay? The third assignment I have for you is some more graphing practice. In general, we did really well on our quick checks, but I did see some mistakes here and there. So I'm gonna give you guys a little more practice, and we'll have our test coming up next week. So I wanna make sure that we start to review for that as well, okay? So 3 Khan Academy assignments and finish page